So hello everyone, Chris Schneck here. I am our business development manager on the business development team. I also oversee some of the Latin America market, the Europe, Middle East, and Africa market, and then the Asia Pacific market as well. So I'm happy to be here.
Yeah, that covering that global region helps bring in a lot of different perspectives of safety and how people address safety in their specific environment. So what we wanted to do today was share with you some of those best practices and go over the evolution of safety equipment from PPE all the way up through the risk hierarchy. And then we're going to define these and then go through and give some examples. And we want to make this an interactive one. We want feedback. We want conversation. So as you guys have questions or any additional input to what we're saying, we would love to hear it. So we got about an hour to cover this. Chris, if you want to start walking through kind of defining what each of these levels are. After we define them, we'll jump back in with some products and some conversation around how we can impact each one.
Yeah, like how you can integrate them into your electrical safety program, how they are installed. Again, as Nick mentioned, we are trying to do a new format here where it's a little bit more informal, more engaging to you as the audience. We want you to participate in this discussion as well. And if any of you have a unique insight or experience that you want to share in the chat, not only would we benefit from that, but the other folks on the webinar as well, I'm sure would benefit from that. So as Nick mentioned, I'll quickly kind of define the hierarchy of risk controls. We'll talk and give a brief overview of what our Graceport panel interface connectors are, our permanent electrical safety devices, our PESDs. We might also trickle in some of our GraceSense equipment health monitoring products as well. I'll let Augie kind of lead that. And then, again, we also kind of want to quickly talk about how these are integrated, how they're installed, best use cases or I guess examples.
Yeah, just share some insight.
Customers. Yeah. Whether that be on an international level, as Nick mentioned, from my side, even domestic as well. We want to open that up as well at the end for a Q&A. We do have a poll as well that we'll be asking everyone that's on the webinar. It'll be tailored to specifically what we've talked about on the webinar today. So
there's a lot of safety professionals that continuously join our webinars, which I love. And then I get to call them every month. Chime in. We love your input. We love that chatter in the chat there. So feel free. So why don't we start with Chris? This low rung here, one everyone's familiar with, PPE.
PPE, so personal protective equipment. Ultimately, this is defined by the hierarchy of risk controls as the last line of defense. Using protective gear to reduce exposure to hazards when other controls cannot eliminate risks. PPE includes arc-rated clothing, gloves, and face shields.
Yeah, absolutely. And there will be a little bit of reading. A lot of these, we're trying to be specific and go and clarify. So if you see us referencing a document, it's to get the wording right, to make sure we're having a conductive conversation with you guys.
And so I would say realistically, why we view this as the last line of defense is you can see here on the hierarchy of risk controls, other buckets, other categories of things that end users, OEMs, system integrators, a multitude of different customers could explore as an alternative means for their frontline workers. There's just a lot of inherent risk. While I'm not trying to downplay the importance of PPE, we truly believe that it is the last line of defense. It is something that you should undertake if there are no other means for you to safely ensure that you've isolated the power.
Yep. But as we go through, we'll identify some other ways that you could look at approaching that. It's kind of
Absolutely.
So what's this next one? Administrative controls. What are we defining that as?
Administrative controls is defined as the 5th level of control. So administrative controls involve changing work practices or adjusting work tasks to reduce hazard exposure. This may involve making changes to operational processes and work schedules.
Okay. All right. Yeah.
So I mean, something to kind of touch on the administrative control. This feels like it's more geared towards the actual process and the how that is entailed within an electrical safety program. And one thing that I've noticed in my discussions, whether it be with a domestic contact or even on an international scale, is that we are dealing with a skilled labor shortage. And ultimately, I think some of that has to deal with an aging workforce. Folks that have been in this industry, had frontline experience at some point in their career, maybe multiple points in their career, but now we're starting to see a shift in folks that are coming in fresh out of university, higher level education, are doing some trade schooling as well, working on their journeyman electrician license or different licensing programs as well. So, ultimately having a documented and clear process that is easily digestible is really going to be a big important factor in mitigating risk.
Yeah, and these are things like your toolbox talks to keep that up to the training, the repetitiveness, keep it fresh on mind.
Could you imagine just going to perform maintenance on a piece of equipment and your electrical safety program is
PPE?
PPE, or it's like 1,000 pages and you have to kind of work through to find the processes and the documentation that is applicable to your specific job, on top of the OEM's kind of maintenance documentation that they suggest for their particular assets. It's mind-boggling to think about, that somebody would just suit up in high-cal PPE, reference that, all of that documentation, and just take on a lot of inherent risk.
Yeah, absolutely. There's better ways, because what ends up is that those don't end up being followed.
Right? Our shortcuts end up being taken, or I've done this a million times. Like, I don't need to worry about this. Like, this is second nature to me.
Yeah. You don't go to the toolbox doc because you've been there for a while. They changed the procedure, added something new. You're unaware. There's a lot of things that could slip. So it's why redundancy, just added layers of safety. The reason you want to work your way up this ladder is to avoid any one of those potential slips, those scenarios. So next one, awareness. So that seems pretty self-explanatory, but what are we defining it as?
Yep. So awareness is the fourth level of controlling hazards. Awareness is defined as enhancing hazard recognition and safety awareness among all employees, top down. Awareness strategies include labeling, signage, and visual aids that alert workers to potential electrical hazards.
All right, so that makes sense. It's keep it top of mind, presence, and aware.
Well, the toolbox talks that you were talking to and referring to as well. I mean, certainly awareness on top of awareness, certainly identifying gaps, having those forward-facing discussions with the folks that are actually performing that maintenance. They're going to be the best tool for that resource and understanding, especially if there are pain points. Mm-hmm. If there's processes that are too long or strenuous on the person that's doing the work, that's where you're going to run into some of that complacency and shortcuts that are being taken.
Yeah, there's often a disconnect between corporate and factory floor, and if you don't realize and appreciate the knowledge that exists on the factory floor and work that up into your procedures, that's going to make this so much easier. If you are on the floor, in the weeds, understand what the needs are, what's happening in real life, as opposed to just sending a directive down the hill.
Your high level understanding of how things work. It may not be
in a perfect world
at the level of the nitty gritty detail that is required that you can harness from those workers that are performing that type of maintenance.
The most common one I hear is actually this PPE and the month of August, and saying, yes, that is in our procedures. We should be wearing it. And obviously, if you're writing that, you're like, put this on so you don't die. But it's 120
That is
degrees.
the worst case scenario. We just want to let you guys know that.
But it's 120 degrees. You're in a steel mill that's pumping out 200 degrees into that 120 degrees.
Imagine, is that steel mill air conditioned, or is it's just
not
ambient?
the one I was in? The doors were open, but that wasn't helping much. But then so your visor fogs up, you're sweating buckets into your eyes, and it's So it gets avoided because it's almost safer if you can't see through all that not to wear it. And if you don't get caught.
Think about, I mean, you bring up a good point. Like how, if PPE is designed to be a protective piece of equipment, but yet there are facets to how hard or difficult it makes your job, how safe is the PPE? Again, and I'm not trying to downplay the importance of PPE here. We want you to follow state and local electrical code and follow the documented processes and procedures that you have outlined at your specific facility. But I just want to piggyback on Nick's point here. Just imagine trying to like work with a portable testing device and you're sweating buckets, you're sweating bullets, and you open up, you're trying to make contact, but you know, you're fumbling around with the portable testing device and you make unintentional contact. Again, you are protected because in theory and practice, you should be wearing ARC rated gear that's rated for the equipment. But, you know, think of all of the other variables that are at play when you're trying to perform a maintenance task.
Yes. Yep. Yeah. That's my repetitive theme is that you need to make it easier to do it the safe or recommended way. And hopefully we can help identify some ways to make those things easier, but there are some situations where it's a tricky task.
Yeah.
So, but awareness and keeping your knowledge of what's available in the market and the ways people are applying solutions is a good way to stay on top of it.
And Augie, I mean, I hate to put you on the spot, but you brought up a great point. You know, as I mentioned, we're dealing with a skilled labor shortage. So the best way to get somebody in and trained is by bringing them into your facility and offering that training, that hands-on experience where maybe they're doing some shadowing, or maybe you're bringing in a consultant that can help ensure that you have a compliant electrical safety program. The great thing about bringing somebody in that's fresh or may not have all of that experience is that you can kind of help mold them to the processes that you've outlined within your facility, and then marry that with kind of the additional training and tools that are available to you as a facility.
Yeah, absolutely. One of the best things our expert network offers is the ability to go through and screen your safe work program and help identify both where you're too robust, where you're capable of making it a little bit easier. You don't have to be as intrinsically safe in that specific application. But then it also helps identify gaps and any weak spots that might have been there. And just having that second pair of eyes, someone that's seen a few other facilities, might have interacted with someone that thought about it or approached it in a different way. But that any additional perspective is great. And our expert network, we've helped so many various industries and people. I have an application I'll share later in this webinar, but people give us feedback on really unique, clever ways to improve the efficiency of their operations using our equipment. So this is kind of why we keep doing these things every month, is to share this feedback. We talk to a lot of various people, and but as we get there, let's keep going up this hierarchy. So we're gonna engineering controls. What we defining that as?
So engineering controls is the third level of control. This is defined as they involve isolating a hazard or changing the way a task is performed to reduce exposure to a hazard. This often involves adding safety measures to make the work safer, such as installing machine safeguarding tools.
Yeah, barriers or light curtains.
Yep. I mean, you know, having a fence around a power distribution equipment.
Yep, absolutely.
You know, obviously, that's going to help reduce the ability to have somebody just interact with that, you know, that shouldn't. And again, I just want to touch on this as well. That is kind of one safeguarding tool, but there's still inherent risk involved, right? So something that's outdoors, there's safeguardings that could prevent birds or critters. You laugh, but think about, I think you have an example of that.
I do, and I didn't even tell you the bird part of it, but in my history working at a steel mill, I was the emergency response team. So wandered around, just made sure everyone was being as safe as possible. But we had an outdoor transformer area, rather large, and Chris brings up the fence example because I use that example of a fence around that area as the engineer control, helping keep people out. The same as a panel on a cabinet or any enclosure is that you have to be pretty purposeful, as Chris described, to walk through a fence and go into that hazard. you also have to be pretty purposeful to go through the panel if there's something that's allowing you to work through it. So the same way that a fence can be considered an engineering control, but you can also restrict that same kind of access just by making it possible to work from outside.
Yeah, I see what you're saying. You're correlating having to open up a panel, suit up in high cal PPE, and test on the inside, whereas there are alternatives that can keep that enclosure door closed,
Keep you out of that hazard.
Keep you out of the hazard, help with elimination of that hazard, and reduce the overall requirements at this bottom bucket, again, which would be your personal protective equipment.
Yeah, the owl part of that, we had one night, middle of the night, it was like 2 a.m, pitch black out, and it all of a sudden became bright as day for about 3 seconds.
Yeah, you thought the sun came out.
Yeah, and then it went really pitch black, and you realized it wasn't pitch black before, but an owl had landed in there and bridged 2 of those phases.
Oh, no.
And it just, it was crazy. So yeah, I can't believe you brought birds in that situation.
Yeah.
But yeah, some things you're not going to be able to avoid, but the fence wasn't going to keep that out. But we don't want accidental contact with these things. That's why equipment's in an enclosure. So don't open that enclosure and expose it to everything else when someone took the effort to put it in there.
Yeah, exactly. And again, I think the point, and I think you're trying to, what the picture we're trying to paint here is that a lot of these are kind of correlated or complement each other very well. Ultimately, we want you to kind of start at the top, and again, the bottom be your overall last line of defense there. But again, there's going to be probably overlap on each individual one of these buckets, especially as it relates to those day-to-day maintenance tasks.
Yeah, what procedure you're looking at. So
exactly.
How are we defining substitution up here?
So substitution is the second most effective method of controlling a hazard. This involves replacing a hazardous material, ingredient, or piece of equipment with a less dangerous one. The idea is to replace an occupational risk with something that has no risk or very little risk at all.
All right, that makes sense with that title.
Yeah, well, I mean, substituting, right? I mean, obviously there's probably going to be safeguards and other things that you can implement on maybe a retrofit scale. So like, say you brought in a piece of equipment that you're like, this is great, and we have a clear defined process, but there's just still a lot of inherent risk here. So like, let's look at maybe adding a safeguarding tool or a resource that will help reduce that risk. Again, substituting for a lower risk is ultimately the key objective within this category here.
All right, and then our top tier best control method is going to be elimination.
Elimination, right? So elimination is the highest level in the hierarchy of control, and it is considered the most effective way to control a hazard. This involves completely removing the hazard from the workplace. By eliminating a hazard altogether, any potential harm or injury is prevented from happening.
All right. So I wanted to get through that because what you were bringing up is these overlapping does come up a lot in conversation. And it's one of those things where helping talk through that, having conversations around it, helps you understand why they would potentially overlap.
Yep.
So we were using our R3W voltage indicator as the example here. And it's showing it anywhere from administrative to engineering controls. So the reason what we're looking at for that is right now you can see there's a label that goes involved with it. That's going to be obviously awareness. It fits right in there with that whole description.
Yeah, I mean, I would say administrative controls, as in like signage and having a clear documented process.
Incorporating it into your procedure.
Incorporating it into your procedure, exactly.
And then your indicator is the prime example of awareness. So it's going to flash at you when that hazard's present, and it's going to disappear when the energy dissipates and there's no hazard left. Where this starts flowing into engineering controls is that if you lose a phase while this is on your equipment, you can identify that and troubleshoot through this piece of equipment by seeing your phase go out, it'll show up in ground. That now becomes an engineering control because you have made it possible to troubleshoot and identify that in a safer way than what you had without the product.
Yeah, and I mean, I would also say that you could kind of make the case for substitution as well, right? Because it's an externally mounted device that keeps the enclosure door closed. So instead of having to, suit up in high cal PPE, and again, I just want to reiterate, I'm not downplaying the importance of PPE. If you're not able to kind of easily verify and test for voltage, we do have devices that allow you to perform a contact test for absence of voltage verification and testing. But if you are not able to verify a de-energized state safely through these types of engineering controls, administrative controls, ultimately the result is having to suit up in that ARC rated gear that's rated for your equipment and testing and troubleshooting on the inside of your panel.
Yes, absolutely. Yep. Yeah, we always want people to err on the side of caution, but just going over these controls, up in the check vault, elimination and substitution. So elimination, if I'm correct, is because we're not opening that panel.
That's
so
exactly right.
No arc flash risk to perform that.
Yeah, and I mean, they're built with a potted construction, right? So they're built with a potted construction. They're built with current limiting high impedance resistors. So the idea is we're trying to reduce that risk or eliminate it altogether. So the device comes standard as a UL listed device up to 1,000 volts. It'll also carry an IP rating of IP69, and it will also have an IP2X rating. So for folks that aren't familiar with what an IP2X rating is, it is touch and finger safe, right? So this is actually, sorry, I'm finagling this here, trying to learn how to make sure I hold this. I can't zoom in, but this is actually a check volt device that we have wired into 110. So it's just, demonstration purposes, but the idea here is that you can easily verify power on each phase. And if there's any stray or voltage leakage to the ground, you'll be able to identify that through the built-in dual redundant LEDs, and also use a portable test instrument. So it is a 2-in-1 device. So not only does it provide the visual, but it also allows you to use that portable test instrument, such as a fluke voltmeter or a multimeter, for contact absence of voltage testing.
All right. And while we were at Modex, was that last week, 2 weeks ago?
I think it was 2 weeks ago, yeah.
When we were in Atlanta, I had 2 companies come up and tell me this. And this is such a fun application for the check vault. But we've demonstrated our recommended live from Grace using the check vault. We have customers now that are using the check vault, installing it on both the line and load side of their isolator boxes. And they're using the load side, obviously, for testing absence of voltage on the equipment. The line side, they're using as their good known source of voltage for that live
right, yeah,
part.
because depending on how far upstream you isolate the power, there might be some residual or power continuing coming in on the line side.
Yeah, so, and that, when you're looking at what that installation of those 2 check volts does, you're obviously going to mix it in with your procedures, so it's going to be part of your administrative control. You get the awareness because you're getting on both line and load side presence of voltage. You can see when it's not there. You can troubleshoot through it, which is moving you through these engineering controls. And then when you're performing absence of voltage, you're not having to open up and expose that risk. And you can see how we're able to climb away from relying on PPE to keep us safe in that scenario. And that is a very unique way. And we even added the awareness. We didn't have a line side check volt label. So we came up with it. By the way, if you're one of those companies, we now have a line side check volt label. If you're putting check volt on the line and load side, we will provide that line side label. If you needed to indicate that that's being used as the known good voltage source, that I believe that's on that one. But if there's a way that we can customize these to best fit your procedures, we're more than capable of doing that. So we love those ideas. We love that feedback. Anytime we can do that, that's fantastic. So any of those customers, reach out for information on that. We'll get you everything you need.
Yeah, well, and again, I think the point Nick is trying to make here is that ultimately our products will kind of fall into any of these top kind of buckets that you see as on the hierarchy of risk controls. So as these devices are implemented, there will be kind of training and processes and procedures that need to be rolled out to the folks that are actually doing the work. So not only will you see a risk reduction, but then we also want this to be easily scalable, that anyone, whether you are, depending on the type of work, right? Whether you are a qualified electrical worker or a non-qualified electrical worker, ultimately you can leverage these types of devices based on kind of the type of work that needs to be performed into your specific task duty at your job.
All right. So just because that's how we started in the 90s, where would you put gray support on this? Oh, you got one.
Yeah, I actually have one. So this is our new MagView magnetic housing. But for the purpose of this discussion, ultimately, I would say that gray supports can be attributed to kind of the elimination or substitution, along with, honestly, probably pretty much any of these. Because realistically, these are going to be panel interface connectors that keep your enclosure door closed. These are geared more towards, I would say, that control voltage side of things. So industrial control panels or ICPs or power distribution equipment. Ultimately, the idea here is you can externally mount these devices and totally customize it, whatever your requirement is for your specific job. So you can throw in power, you can throw in RJ45s, you can throw in USBs. Ultimately, we want you to be able to easily walk up, perform quick and easy data access changes or programming changes locally at your equipment with as minimal risk exposure as humanly possible.
Yeah. So, and again, depending on what your procedure looks like now, we're either that could fall under elimination, or if your equipment's designed with the engineering controls to put physical barriers in, it could be less effective or more effective depending on what the actual situation is that you're resolving. Obviously, if there's no hazard and you install gray support, you're not eliminating any hazard.
Yeah, so right. But then again, I think that there is correlation and kind of overlap between awareness, right? Because they're externally mounted, it's right there in your face, and it's hard to miss. Mm-hmm. Ultimately, if you need to make local changes on any of your assets, whether it's a press or a conveyor, like changing the speed of the conveyor, ultimately that's usually done locally at the actual asset itself. And we have tools available to you that will make your job easier, more efficient, and more productive.
All right. Is there, what's next on our list, or do we want to see what?
Yeah, I think we did a good job of kind of touching on where our products fall into each category and kind of the added benefit of that. Ultimately, I think we touched on the substitution, and the elimination piece, ultimately keeping that enclosure door closed, providing you a different alternative to testing for absence of voltage. I just want to, again, distinguish between just LEDs alone and our check volt, because again, the LEDs are used to verify presence of voltage. Our, task qualified workers, if they wanted to do a mechanical lockout tagout, that generally correlates back to a bump or a try test that you use in conjunction with our voltage indicator. But as Nick mentioned, there's been a lot more interest in verifying a de-energized state. And so that will come into play with any of our contact test points and our check volt. Like I mentioned before, the check volt will have built-in dual redundant LEDs and high impedance current limiting resistors to allow you to use a portable test instrument for both presence and absence of voltage testing.
Yeah, and then some of the other things that I did want to just have a conversation around. So like our hotspot monitor, something like that would be replacing thermography, which a lot of the companies that choose to invest in the hotspot monitor are hiring contractors to perform that. So they have a dedicated team, but they're doing it infrequently and they're not really utilizing them to the best of their ability. So, they may run a scan on a somewhat irregular cadence, like once a quarter, biannually, annually, and they're not getting a clear and accurate picture of their equipment health. Sometimes they're not even running their equipment under full load. Do you have any experience with companies that are doing a procedure that was documented but doesn't make sense? A case, I was somewhere recently that performed thermography on an annual basis because they were required to.
Oh,
however,
for like insurance purposes or something, I assume.
But they described it as absolutely useless because the majority of time when they went to test, it was an R&D facility, so none of the equipment was powered.
Yeah.
So
Well, I mean, an R&D facility, right? As the name explains, it's a research and development facility.
Yeah, but they had to do, they would pay every year over and over again, and they knew it wasn't doing anything. And it's so sometimes it's being aware of what exists out there, something that's continuous that you can data log when you know it's running. That's the insight and the value they saw.
Well, yeah, I mean, I think you bring up a good point, like challenging the status quo. You know, ultimately, just because you're doing something, it may not make the most amount of sense to continue to do that thing based on the output of the value achieved or even perceived at that point. Because as you can tell, in Nick's situation, the perceived level of value was basically zero or non-existent at that point.
Yeah, we get that feedback a lot. So what the conversations we'll have is the people watching our webinars often understand the points we're making and agree with this. We get asked to help sell to the bean counters, the people that are cutting the checks that aren't in here, that don't realize the safety or the efficiency value. So is there something that you've done or anything? How do you normally help have those conversations? You just engage a local team or?
Yeah, I mean, I think having, at a local level in your facility, roundtables that allow folks from other areas of your business to kind of come in and hear or maybe even see what your day-to-day operation looks like.
Oh, like invite them to a toolbox talk or something you're going.
Yeah, I mean, a plant floor walkthrough, having discussions on pain points, what's working, what's not working. You know, ultimately, this does need to be a buy-in top down. Everyone needs to be engaged on this. And it's not just the people that are actually putting their lives on the line and those frontline workers, as I like to call them.
All right, and then we have some what seem to me over the top, but I know there's specific situations that warrant them. But we have like our fiber optic voltage indicator. What is the situation? I think you're the Asia Pacific region uses more of that.
I was actually just in Australia, and what I'm finding is that they operate under a star delta system. So historically in the US, right, you're dealing with a delta or a Y orientation, right? That could be a four wire delta or a 5-wire Y configuration. The star delta is equivalent, very similar to the Y system that you'd find in the US. And so they actually care a lot about their reference test point against a neutral. And the reason that they're opting for a fiber optic is because they want extreme low voltage to the door. And so I reiterate that we do have fiber optic solutions, and the primary industry that I'm focusing on in Australia would be like those mining applications where I actually got to see some of our equipment, and oddly enough, I've seen photos of large mining vehicles, but until you actually stand next to one,
climb the ladder.
It's like I felt like an ant looking up at a giant. But those vehicles in and of themselves are basically their own power system. They have PDUs, they have isolator switches, they have power distribution that is built into the actual mining vehicle itself. So I actually was able to configure a custom solution that was geared towards 1500 volts. That was on the DC side. And then I also put together something that was geared towards 800 volts on the DC side. And so as you mentioned for your customer, they were leveraging a combo unit that looked at a DC voltage indicator and a DC test point that allowed them to test both line and load all in one device.
All right.
So again, it's just redundancy purposes, making it a little bit safer. And as you can imagine, like me feeling like a little ant, looking up on this vehicle, just imagine having to climb up and like be mobile and test for presence and absence of voltage on that mining vehicle.
Yeah.
Like I just, ultimately we're just looking for ways to integrate engineering controls that eliminate, substitute for lower risk, and provide more awareness.
It was nice and cool when you were there, though. You wouldn't have been sweating in PPE.
I was in Australia at the kind of the end of their summer season.
You came back sunburnt.
So I learned a valuable lesson to wear layers even when it's hot. I burn very easy, and it's funny, oddly enough, and maybe this is TMI, but on some sales calls I was wearing a red polo shirt. And a polo, like, so you could still see my arms, but they were beet red. And so it just, I look like a lobster walking around talking to these accounts and customers. I learned a very valuable lesson, but I also, on a more serious note, I was really able to get in front of some key customers in the mining industry. Switchboard builders is another one.
Absolutely. Yeah, things like our
portable
hotspot monitor big for that.
Portable systems as well, where they would build out like a full-blown room, and then they would transport it to a facility as well. It was cool to see our solutions. Cool. Yeah, it was cool to see our solutions integrated on a wide array of systems. And one key takeaway, I'm word vomiting here, so I apologize. But one key kind of takeaway that I learned is that back panel space is very important. So while there might be some other offerings on the market that you could explore, one thing that I noticed, and from like our competition, is that they consumed a lot of back panel space.
Yeah.
And with our solutions, it's just one 30 mil hole punch knockout, and then there's 4 or 5 wire leads, depending upon which component that you opt for, that you route in parallel to your source voltage.
Yeah, there was such a drive to make the PESDs. The biggest feedback was we love them, make them easier for us to install and use. And because we had the gray sport with the 2 side by side, and people are like, just
the voltage test station, and then the knockout, and then our combo units. Yep.
Yeah, but once that 30 mil one size got in there, people are like, hey, there you go, home run, hit the nail on the head. You figured out what we're looking for.
So I think kind of correlating this back to the big picture. I apologize, guys. I get excited about electrical safety. So kind of tying this back to the big picture here, guys. How does this kind of fit in, Augie? And if you want me to answer this, I can. But how does this fit into kind of that isolation of power testing, our absence of voltage test, and that point of work? I feel like point of work has been brought up quite a bit. I think we should address that and kind of talk about how we perceive that and what feedback we've gotten from the NFPA 70E committee and how our products fit in.
Yeah, and that ties back into understanding the product that you're using and how it functions. The NFPA technical committee views products like our check vault as an extension of the point of work. So if you know where the leads are installed and you know where you're testing and that is where you intend to be testing, you can just do so safely from the outside. That is our approach.
Yeah, so that's what we recommend. Obviously, with these devices, we want the leads to land, in essence, where you would actually be doing the test internally on your equipment.
Yeah, and in some cases, like you said, people will install them side by side to hit multiple landing spots so that if they need to confirm multiple spots, they can do so. So
exactly,
whatever fits, we usually in that case label exactly what they're testing with each port and all that. But yeah, there's a lot of different ways people apply this, but every facility is operated a little bit differently. You get people that go through acquisitions and they end up with facilities that have different color wire down to different procedures and everything. So
yeah, and I think that this also ties into kind of the broader discussion that we were having surrounding PPE. Again, I want to reiterate that our permanent electrical safety devices, our Graceport panel interface connectors, these are not PPE devices, right? They are extensions of that source voltage, are engineering controls, are tools that you can leverage to have a significant impact on your process and your procedure, especially as it relates to lockout tagout. What I've seen and feedback that we've received from the field is that not only are these very easy to install, but ultimately customers receive a payback, and in some instances, one lockout tagout procedure, or even just one programming session. Ultimately, these have intended uses and kind of their own use case, but they're very low entry points that can have a significant impact on the culture of safety at your facility.
Yeah, absolutely. And there's a lot of different configurations. So whatever best fits is what we're looking for.
Absolutely, absolutely. And so ultimately, that is kind of the big driver between our Graceport panel interface connectors and our permanent electrical safety devices, specifically how they fit into the hierarchy of risk controls. And then ultimately, as Nick mentioned, touching on that absence of voltage test that's outlined within NFPA 70E as well. I do want to reiterate that the use of permanent electrical safety devices in conjunction with, so used in conjunction with portable test instruments, are an appropriate means for testing and verifying both presence and absence of voltage that's outlined within NFPA 70E.
All right. Is that a poll up, or we got any comments that we can address?
Yeah, so I think the poll that we're going to bring up, guys, we touched on a few different things, some more than others, but my team would love to follow up with you. We'd love to chat with you about your unique processes and procedures, and ultimately have a very specific discussion on what interests you, whether that be our Graceport product, our permanent electrical safety devices, or even the expert network, as we mentioned as well, kind of assessing and looking at your electrical safety program, checking, kind of doing stop gaps on the robustness and ensure compliance.
Yeah, and there are instances where people reach out, because we have a wider network of associates and help that we can reach out to. And there are people that will reach out to Grace looking for safety solutions that we don't have anything to address, but we have a network we can connect you into. So if you're looking for help on a solution, feel free to reach out. We might have had that conversation a couple hours ago with somebody else. You're probably not the only one in your situation. So if there's help to be offered, feel free to reach out for some follow-up. And me and some of my coworkers will give you a call and do whatever we can to help.
So I do want to open it up for a Q&A. I really appreciate everyone's time that was given to us, and I hope that there was some valuable information that you learned from this discussion. Again, we try to keep these educational in format, so really kind of a high-level overview of the hierarchy of risk controls, how that ties back into NFPA 70E, and then ultimately some resources and tools that are available to you at your disposal to, again, reduce or try to prevent you from having to suit up in those high-cal PPE spacesuits and take on a lot of inherent risk when you're working on electrical equipment. So let's see, what are some questions that have trickled in?
All right, so the first question is in regards to PPE requirements when testing using PESDs. Now, they did mention voltage portal. I think what they meant here was our test point, but if you want to take this opportunity to also explain the
difference between a voltage portal and then answer the question about PPE requirements. Nick, do you want to?
You take the voltage portal, I'll take the PPE.
So great question. Ultimately, this is going to be driven by state and local electrical codes and the processes that you outlined within your electrical safety program. I can talk to you about the voltage portal piece. We went to market with a solution that we called a voltage portal that was used in conjunction with a non-contact voltage detection pin, right? So you turn the pin on, you get it close to the non-contact portal, and it would beep. It would beep and it would light up, right? But in that situation, you are not making a physical contact. You are the ground in that situation. So with that in mind, you can still use a voltage portal or a non-contact solution in conjunction with our voltage indicator, just as redundancy. I feel like we've beat a dead horse on that word here on this webinar, but for redundancy purposes, having an additional means of testing is a great way for task qualified workers, and maybe some of those non-electrically qualified job duties that need to be performed. But we noticed a gap, and so that's ultimately where the contact test points and a slight deviation, rather than calling it a voltage portal, we call them our safe test points, our check volt, and some of those other solutions, which I'll let Nick kind of answer there as well.
Yeah, and there are a lot of people that have different words for a lot of our products or these types of products. I like getting people on like virtual meetings so that we can at least share pictures and assure that we're talking about the same things. But I know I've seen specifications that call that a portal.
Yeah.
So it is clarity in what you're talking about is really big. Specifically with the check vault and PPE requirements, it is touch safe. This conversation comes up a fair amount. A lot of safety professionals just will recommend use of ambient PPE.
Ambient PPE, yeah.
Gloves while you're using it, especially
Safety glasses, you know, a hard hat.
But like if you're on a ladder,
steel-toed shoes,
probably not the worst case to have gloves on just in case you come in contact with anything, or that kind of the CYA kind of redundancy. But it is your normal operating conditions if you're not opening up and exposing any additional risk. So ambient PPE, what you're required to walk by, is what this is requiring in itself. But then your local guidelines, your procedural steps, if it's don some gloves just before you test, that's a simple task to add on there.
Yeah, and I mean, that's one point as well, just to add, and then we'll move on to another question.
Using this doesn't mean you can't use PPE.
Yeah, I think that's a fair point to make. And this is not the elimination of the requirements of PPE. Again, I feel like I just want to stress to you again, these are not PPE devices. So PPE is still very important as a means for reducing risk. This is just kind of a engineering control or a tool that you can use to help you with your day-to-day tasks.
Yeah, but it needs to be integrated appropriately. It's not, you shouldn't be buying one of these, slap it on a panel, and then creating your own lockout tagout routine, because that task can be made easier. It needs to be incorporated correctly, because otherwise, if you're not, you're still going to be going against your company's established procedure, which is not the intended way of using these.
Yep. I hope that answers your question.
Yes. Okay, so a few questions came in while you guys were going through the pyramid, and I think you were kind of answering them in real time, but we can kind of just touch on these really quickly again. So the first one is GFCI. This one we actually didn't address. So GFCI and arc flash relays, would these fall under engineering controls?
Yeah, that is correct. And then, with the GFCI, obviously there's ground fault detection in the actual GFCI itself. I've also seen customers add in a external circuit breaker. I can't tell you how many times I've been on a job site where I've seen, a multitude of things plugged in for power on these types of devices. So I always like to stress and relay the importance of, I would say almost all of our Graysport products, they are padlockable. So if you wanted to restrict access, and you laugh, but I'm just saying, I've seen people plug in like vacuum cleaners.
That's one of the common ones.
I know.
It's surprisingly common. Hammer drills, everything.
But yeah, so sorry, I'm getting off track again. But yes, I would say engineering controls would be kind of the primary, ultimately kind of the bucket that would fall into, and then also probably administrative controls as well. Mm-hmm. And awareness.
That was one of the first questions I was asked about the MagView is, can you put a padlock on it?
Yeah, yep, it is padlockable. So I hope that answered that question. A lot of
specs. Yeah.
Another question that followed that was, and I think we covered this with the check vault, for example, but what would be examples of substitution for arc flash hazards?
Examples of substitution. So, I mean, ultimately you could look at permanent electrical safety devices. Ours are, one offering in this space, the kind of the Graysport as a means for through the door data access and connectivity. And then also, I mean, I would say at a high level, anything that like prevents those frontline workers from having to take on exposure or risk at the actual equipment that they're working on. So, that could be an equipment health monitoring solution. That could be a safeguarding tool, signage, having a clear documented process and procedure. I would say that those are tools that you could potentially look at in terms of trying to substitute around that risk. What do you think? I mean,
I was trying to come up with a specific one, but I'm not.
Yeah, I mean,
not grabbing one right off the top of my head.
Yeah. So reach out to us and we can have a conversation with you on that as well.
And then just one more time, I know we explained how check vault falls under elimination because it eliminates that step of opening the panel. But if you guys want to reiterate that, there was another question about that.
Sure. So this solution is installed externally. It will come standard with 4 wire leads, 1 for each phase, 1 for the ground. The idea is that this keeps your enclosure door closed. So overall, that incident energy that lives on the inside of your panel will remain inside of that panel, right? There is no added arc risk or incident energy exposure through this device. As it is an industrial solution, it will carry category 3 ratings up to 1,000 volts, category 4 ratings up to 600 volts. And then, as I mentioned before, it is a UL listed device along with carrying IP69 ratings and that IP2X touch and finger safe. So realistically, because it is an externally mounted device, it eliminates the need for you to have to open up your asset to do that absence of voltage testing and reduce that overall incident energy exposure. Anything you wanted to add?
No, I think you hit it. Hopefully that cleared it up a little bit for anyone that was asking.
Nick, you'll like this one. So someone had asked about the hotspot monitor. Is it a continuous thermal monitoring device?
It is. So that one, the way I've seen it best integrated is insurance companies will actually allow it to be used instead of thermography, but it is a continuously monitoring thermal monitoring device, and it actually has like almost 20 years worth of onboard storage. So you can use it to go back and trend and find specific periods in time and data log that way, versus sometimes a very limited insight you get from thermography. So yeah, it's a new upcoming exciting way to manage that, and gives you a lot, especially if you're gathering data. It can add a lot of insight with data. And if you're interested in that, you'll love talking to Shelly, and send me an email and I will connect you guys.
I don't know the answer to this question, so I'll be interested to hear what you say. Does this new Graceport product, I'm assuming the MagView housing, work with the mount that allows you to forward face a side-mounted device?
We have a mount like that? Is that a Grace product?
Yeah, I'm not sure exactly what that...
Well, I think the question, so the way that I would think of it, it'd be similar. So think of like our flex mount voltage indicator, how you can orient it in ways that allow you to install so that the face of it is facing towards you regardless of where it's mounted. So I think he's asking, he has a component that would allow him to mount a Graceport but have it kind of forward facing, which...
I think he means... So there was a water wastewater facility that we had an externally mounted. We ran a conduit from a panel. Voltage test station.
Yeah.
So he says, I would prefer to not have these mounted on the cabinet door, but still have them forward facing.
Yeah. Okay.
Oh,
so
yeah. We have like conduit style.
Yeah. I mean, we have
mountains.
like, it's like a polymer box or some type of box that allow you to kind of separately mount whatever solution you opt for, whether it be a Graceport.
Is that what we use for GraceSense a lot for those?
I would say the example that Nick Schultz was using was on our voltage test station. So the voltage test station was in a housing that looks like this, but it was mounted separately from their asset, and then conduit was routed to the actual panel that didn't interfere with the actual panel itself. So we do have some options available if that was something that you wanted, to not modify your asset or your panel and just route kind of conduit for the connection points. That is absolutely something that we could do and still have it more of a forward-facing solution for you as well.
And if you want an example of that, I believe I have a picture of that in a case study. So now that you're reminding me which one you're talking about, absolutely. All right, so I think that's it for the questions. Is there anything else that you want to address before we wrap it up? I love the interaction, you guys. Thank you very much.
Yeah, I mean, I just want to say thank you again. I love doing these webinars. It's ultimately a great way to convey some of the conversations that we have on a day-to-day basis. So I really hope that there's something valuable that you were able to gain from this. And, we truly value your feedback as well. So if anyone's interested in providing us some feedback, please reach out. We'd be happy to chat with you about your unique application and work on getting something configured for you for testing.
Absolutely. Feel welcome to reach out for follow-up. We love chatting with you guys. staying up to date with what's going on in the field.
Okay. Well, guys, thank you so much. I hope you have a great day. Take care.
Thanks.